Let's first discuss the distance-time graph. In this graph, let us take time along the x-axis and distance along the y-axis. Distance-time graphs can be made by considering two situations. Either the object moves with a uniform speed or with non-uniform speed. First, we will consider the case of uniform speed. If an object is moving with a uniform speed, we know that it covers equal distances in equal time intervals. We can say that the distance is directly proportional to the time taken. So, let's start by plotting the graph. Suppose the object covers 10 meters in the first 5 seconds. For the next 5 seconds, it covers another 10 meters and so on. Mark the points on the graph. If you join these points, you can see a straight line passing from the origin. Thus, for uniform speed, a graph of distance travelled against time is a straight line. If the magnitude of displacement is equal to the distance travelled by the object, then we can use the term uniform velocity in place of uniform speed. We can also determine the speed of an object from the distance-time graph. The speed of an object is determined by calculating the slope of the distance-time graph. Let's calculate the speed of an object in the previous distance-time graph. Choose 2 points A and B on the graph. Draw a line parallel to the x-axis from point A and another line parallel to the y-axis from point B. These two lines meet each other at point C to form a triangle ABC. Now, on the graph, AC denotes the time interval while BC corresponds to the distance. We can see from the graph that as the object moves from point A to B, it covers a distance 30 minus 20 is equal to 10 meters. In time, 15 minus 10 is equal to 5 seconds. The speed v of the object can be determined as v is equal to distance travelled upon time taken. Speed is equal to 10 meters upon 5 seconds is equal to 2 meters per second. What if motion is an accelerated one? We can plot a distance-time graph for accelerated motion as well. Given here is a table which shows the distance covered by the car in the respective time interval. Can you plot the graph using the data in the given table? Once you plot the points, your graph will look like this. The nature of this graph shows non-linear variation of the distance travelled by the car with time. Thus, the graph shows the motion of an object with non-uniform speed.